Hello, and welcome to Crazy Math Productions. Today we're looking at Chapter 4 Test Review for Algebra 1 Honors. This will cover graphing lines, graphing linear equations, looking at slope-intercept form, standard form, and those types of things. So let's go ahead and get started. Slope ratio. Well, the slope ratio, m equals rise over run, divided by the run. You could also think of that as a vertical component, change in the vertical component, divided by the change in the horizontal component. Slope formula, traditional slope formula, m equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Now, what's important is that the y's are on top and that you're being consistent. Y sub 1 minus y sub 2, x sub 1 minus x sub 2 is also correct, but this is the standard classic formula. Standard forms ax plus by equals c. Slope-intercept form is y equals mx plus d. Shortcuts. Well, m equals the opposite of b over a. Excuse me. Shortcuts for signing the slope-intercept form. Let's start with the slope-intercept form. Y equals mx plus b. We're wanting to get that ax plus by equals c into this slope-intercept form to look at those shortcuts. So by equals subtract ax from both sides and then divide by b. And so you can see this is m, this is b. So the shortcuts, m equals opposite of a over b. That's how that is derived. If you forget, just thought that might be helpful. And b is c over b. Those are those shortcuts. So really, you could take this formula, manipulate it one time, then have the shortcuts to be able to use it the rest of the test, which is a pretty good idea. Okay, equations and slopes of vertical horizontal lines. Okay, well, the y-axis, this is the y-axis. Well, a y equals line is the opposite of the y-axis. It's this. This is a y equals line. So this horizontal line is going to be y equals some kind of a constant. A vertical line, now notice, this is the x-axis. X-axis is like this. Well, that means an x equals looks like this. That's a vertical line. So it's an x equals some sort of constant. What are the slopes of these? Well, a horizontal line, m equals 0. This is a horizontal line. You could think there's something called Line Rider. You could go to linerider.org and you notice you get a little man on a little sled. And what happens is that little man will, you could draw a little line on a page, and the little man's going to drop down the line and jump off, that sort of thing. Now, if you think about a horizontal line here, little man's going to fall on the line, and he's not going anywhere. He's going 0 miles an hour. So, the slope of a horizontal line is m equals 0, because that's how fast he's going. Now, if you think about a vertical line, on Line Rider, the man would spawn somewhere right here. Now, the question is, how fast is he going when he hits the line? Try that again. How fast is he going when he hits the line? Well, the thing is, he never will. So it's sort of a trick question. Now, algebraically, we think of this as division by 0. The change, the rise, we could say maybe 5 units. The run is 0 on this particular line. So we're going to be dividing by 0. We cannot divide by 0. So I say m equals undefined. Now, some people say no slope. I don't particularly like that, but that is pretty commonly used. So m equals 0, or y equals a constant for horizontal lines. For a vertical line, x equals some kind of constant, x equals 5, x equals 6, or m equals undefined, or m equals no slope. So you need to know those going into the test. We also have find the slope of the line in the given situation. um, well, apparently I don't have this graphed here, but we'll make one up. So this is going to be different in the test review than handed out, but that's all right. Now, sometimes they will actually give you some points to work with. Sometimes they won't. What you have to do, try to find, you'll notice, let me highlight a few of these for you. This is a perfect grid intersection. This is a perfect grid intersection. It's where there's sort of a corner in the coordinate plane, if you will. All these little blue dots are perfect grid intersections. Perfect grid intersections, excuse me. And that's what we're looking for. So you notice this is a perfect grid intersection, as is this, so we can use those. Now, you could use others, it doesn't matter, but it does need to be a perfect grid intersection, exactly where your linear equation will go through a perfect grid intersection. Now, my students will like to be going on a journey, and we get to choose. You get to choose which point you're going over. Now, I do suggest you go ahead and draw a box around there. And now we're going to look. Let's see, let's use. There we go. All right, now I want to start from the bottom dot. Why not? I get to choose. Top dot, bottom dot, point, doesn't matter. There's only one slope to a line. There's only one slope to a line, so it shouldn't matter which way you go. It will not matter which way you go as long as a vertical component is on top. So what we're going to do, we're going to say, well, I'll go up just because I want to. So that means I'm going up 1, 2, 3. Now remember, this is positive, this is negative as far as the change in the vertical component goes. Let's say positive 3. Now I'm going to go left 1, 2, 3, 4. Now left is negative, right is positive, so it's going to be a negative 4 that I'm going left. Now m equals the rise over the run. You have to use that several times. So m equals 3 divided by negative 4. And that's my slope. Do realize that the slope, you could have 3 different versions here. The negative, we could have 3 divided by negative 4, as we have here. We could have negative 3 divided by positive 4. We could have negative out front, and then 3/4. It does not matter where that negative goes, as long as you just have the one negative. Okay, now, 2 different ways you can look at the line passing through 4, negative 3, and 4, negative 7. First, you could label them x sub 1, y sub 1, x sub 2, y sub 2, and then do the traditional formula. Y equals y sub 2, which is negative 7, minus y sub 1, which is negative 3, divided by x sub 2, which is 4, minus x sub 1, which is 4. It's going to give you, I like to keep change. Absolutely not necessary, but I just prefer it. Negative 7 plus 3 is going to be negative 4. They fight, negative wins, and there's 4 left over, divided by 0. Now, division by 0, if there's a hole above you, that's not a problem. If there's a hole below you, that's a big problem. So this is not going to work. This is not defined by the rule for division, definition of division. So this is going to be undefined. M equals undefined. Now that's one way to do it. That's the classical way to do it. But my students in my class, we do it a little different way. I will actually draw, it's going to look probably like an alligator or a giraffe or something, but that's all right. I like to draw a puppy. And if you're familiar with puppies, basically what you can do is you can grab them by the scruff of the neck here. And the 13th, now it's very important the dog faces to the right. Make sure he's facing the right direction. But if you picked him up by the scruff of the neck, that's what the little mama dog likes to do. The 13 would be in the top, and the 4 would kind of dangle underneath. Same thing would be true of this. Puppy's facing the right-hand direction. You pick him up by the scruff of the neck. The 5 would be on top. The -2 would sort of dangle below. And it's just a very stupid way to remember that, but sometimes a dumb way to remember it's a good thing. Now, it's one fraction. We're going to keep change, and see what we get here. 5 plus -13. They fight, the negative wins, and there is 8 remaining. They join, negative wins, and there's 6. Now, negative divided by negative, we do need to simplify this. This will be a positive 8/6 reduced to 4/3. Now, can we make it into a mixed number, say 1 1/3? No, we cannot. We need to keep it as 4/3. The reason is the slope is a ratio. It's a comparison of the rise and the run, and we need to see that ratio preserved, so we don't need a mixed number. Okay, write the following equation in standard form. Well, this blank here is for your standard form. That's what we want you to put. So y equals mx plus b. I'm going to cheat. I know already, since this is in slope-intercept form. Oops. I know this is m, and this is b. So since I have it so nicely written for me, I'll go ahead and put that in. But it does want standard form down here. So what I'm going to do, I need to clear this fraction. It doesn't matter which order you do it in, but I like to clear the fraction first. So I'm going to multiply by that 5. Distribute it to each part, separated by an equal sign or addition or subtraction. 5 times y is 5y. I'm going to divide by the denominator, multiply by the numerator. 5 divided by 5 is 1, times -2 is -2, and that's -2x. 5 times 6 is 30, so minus 30. Now I need the x on this side, on the left-hand side. -30 can remain there. So I'm going to add 2x to both sides. And we get 2x plus 5y equals -30. Now how do I know that's in standard form? Several reasons. Number one, there's no fractions. No fractions or decimals. A, B, and C must be integers. Next thing, A, B, and C have no common factors. So, for example, if we had 4x plus 10y equals -60, we'd need to divide each one of those by 2. The other thing, A is positive. We need that leading coefficient to be positive. Now, it depends on the literature that you're looking at. Some will say that it doesn't matter. Some will say that it does. So we're going to go ahead and say that A is positive. And that's how you know that that's in standard form. At this time, we need to put it in slope-intercept form. So remember, that's y equals mx plus b. And having slope-intercept form, I need y out in front, which it is. But I don't need these, so I'm going to add the opposite of these to both sides. So -3x plus 3x, that's 0. 7 minus 7, 0. So I'm left with, I'll tell you what, I'm going to continue over here, -6y equals, okay, now what can I combine here? 4 minus 7, both of those do not have x's, so I can combine those. 4 minus 7, it's going to be -3. And the 3x, I'm just going to have to leave as it is. Okay, now I do need y by itself, so what I'm going to do is divide by the number that's in front, you get y equals negative 1/2 x. Now, negative divided by negative is a positive, and there we go. So, negative 1/2 x plus 1/2, that's what's going to go in the blank. How do I know it's in slope-intercept form? Well, y has a 1 in front of it, although you don't actually write that. We have y equals some kind of a coefficient times x plus a constant. Slope is negative 1/2. Y-intercept is positive 1/2. Now these, we're trying to find out, are they parallel or are they not? Well, the easiest way is to put them into y equals mx plus b form. If you'll do that, it'll make your life much, much easier as you're approaching these problems. So I'm going to clear some space over here. Let's see, 3x minus 4y equals 8. Let's see, let's subtract 3x from both sides. Get negative 4y equals negative 3x plus 8, and divide by negative 4. We're getting it in slope-intercept form. So the simplified version we'll put over here right next to this one. So this is y equals negative divided by negative is a positive. 8 divided by negative 4 is a negative 2. Now you could also say y equals 3/4 x minus 2. That would also work. And down here, we'll also need to get that into slope-intercept form. Okay, so I'm going to subtract 8y from both sides. And then subtract 6x from both sides. Remember, I cannot combine these. And now divide by negative 8. I can put the reduced form over here. That's going to give me 1y, or just y, equals, okay, negative divided by negative is positive. 6/8 is 3/4 x plus 3/8. Now, here's the thing. When we're looking at parallel, you think about parallel lines. Parallel lines basically mean that, if you're familiar with traditional definition, they go on and on and on forever without ever intersecting. They lie in the same plane. But from an algebraic perspective here, what we're talking about is that they have the same slope, same rise and run, but they have a different y-intercept. Why is that important? Well, if they had the same slope and the same y-intercept, they would literally be the same line, and a line cannot be parallel to itself. So what we're looking for, first of all, look at the slope. Is the slope the same? Well, yes, it is. Now, we could give you a trick question and say that the slope is the same and the y-intercept is the same. If that happens, the answer is no, only because a line cannot be parallel to itself. But in this case, they have the same slope, different y-intercept, so the answer is yes. Now let's do the same thing for number 7. I'm going to isolate y, try to get y equals mx plus b. So I'm going to clear everything else that's not y from that side. Negative 1 plus negative 2 is negative 3. So we get y equals 5/7 x minus 3/7. Let's do the same for this one. Oops, ran out of room. Okay, so I'm going to add 14y to both. I'll tell you what, there's not enough room over here. Okay, so we're going to add 14y to both sides. And add the opposite of negative 10x, which is positive 10x. And now divide by 14. So we get y equals, let's see, that's 5/7, x minus 3/7. It's very easy here just to simply say, oh, well, they have the same slope, so they're parallel. Problem is, when you look at the y-intercept, it's also the same. These two are actually the same line. So if the y-intercept had been different, slopes were the same, but the y-intercepts were different, then it would have been yes. But in this case, it's no, because this is literally the same line. A line cannot be parallel to itself. Okay, now we're going to start to graph. As we graph, there's several different forms. We have slope-intercept, which for my students, we'll use Moby and the boat. I'll explain that in a moment. Using the intercepts, for my students, that is the googly eyes. Using table of values, that would be the evil laugh. Laugh out loud negative. And this would be the swat the flies. So we have several different bizarre ways of graphing these. Okay, so using slope-intercept form, Moby and the boat, what I like to do, first of all, we have to get this into slope-intercept form. So 7y, I tell you what, I'm going to subtract 21 from both sides. Get 7y equals, let's see, 9x minus 21. And now we'll divide by 7. So get y equals 9/7 x minus 3. So my slope is 9/7. My y-intercept is negative 3. Don't forget that negative. That's very important. And here's the thing. I like to talk about Moby in the boat. Y equals mx plus b. And this is not a math thing. This is just a dumb way to remember it. So what we'll do is we'll start by aiming. Excuse me. We're going to drop our anchor first. So drop your anchor. Aim. And then shoot. But definitely want to miss the whale. I'm not in favor of harmed whales. So we're going to drop our anchor. What do you mean drop your anchor? Well, B for boat. You're going to drop the anchor of the boat. We're going to go, remember that B is the y-intercept. So on the y-axis, we'll go to negative 3. Negative 3 on the y-axis. This is positive. This is negative. So we need to go down 3. 1, 2, 3. And plot our point. Now once we've done that, we want to aim. Well, how do we aim? We rise and we run. Rise 9, run 7 from the boat. We're going to aim for the whale. 1, 2, 3, 4, 5, 6, 7, 8, 9. And run 1, 2, 3, 4, 5, 6, 7. And now we shoot. And of course we miss because we don't want to hurt the whale. So that is how I like to do slope-intercept form. We drop our anchor on the boat, negative 3. We're going to aim, which is rise and run from the boat. Rise 9, run 7, and then we shoot. Graph our line. Now, number 9, I like to use the intercepts. So it tells me to use intercepts. I like to use what I call the googly eyes. Now, I'm not sure. I did not come up with this. I'm not sure who did, but whoever did, wherever that came from, thank you very much. It's a great idea. So I will draw little googly eyes here. Little man. I'm also going to label this X, Y, X, Y. And I'm also going to label this. This is the X intercept. This is the Y intercept. And we'll give them little eyes. Why not? All right. So what I'm going to do is to copy this equation 2 times. Be nice if I could copy it down correctly. And here's the thing. We're going to plug in, instead of putting a y right here, we're going to put a 0. Negative 4 times 0 is 0. That means 6x equals 10. We're going to divide by 6. So x equals 10/6 or 5/3. Now that's my x-intercept, so I'm going to put 5/3. The same thing I do over here. X is 0, so I don't put an x, I put a 0. That's 0. Divide by negative 4. I'm going to get y equals negative 10/4. That's also negative 5 halves. Now, on the x-axis, I'm going to graph the x-intercept, which is 5/3. Now, it's bigger than 3/3, which is 1. It's smaller than 6/3, which is 2. It's a little closer to 2, which is 6/3. I'm going to go 1, 2, and back up just a little bit. There's my x-intercept. And again, that's just the best estimation I can make. The y-intercept. Now, negative 6/2 is negative 3. So on the y-axis, I'm going to go negative, which is down. 1, 2, 3. It's not quite negative 3. It's almost there. And so I graph my x-intercept on the x-axis. I graph my y-intercept on the y-axis. And now I graph my line. So graph using the intercepts, I use my little googly eyes. My little man helps me out. Graph using slope-intercept, that's moving the boat. Drop your anchor, aim, and shoot. A table of values. With table of values, we need to make a table, hence table of values. And I like to use negative 1, 0, and 1. And of course, LOL if you'd like to text. LOL is laugh out loud, and we put the negative on there, so it's like an evil laugh. You know, like a negative laugh out loud. Anyway, so that's our evil laugh. We're going to plug these in. Now, to make it much easier, we're going to put this into y equals mx plus b. The only one you really don't have to put into y equals mx plus b form is the googly eyes. Those, it's not necessary. But for slope-intercept form and for table of values, you have to put it into y equals mx plus b form. So we're going to go ahead and do that. We have 15 plus 3y equals 4x. I'm going to subtract 15 from both sides. 3y equals 4x minus 15. And now we divide by 3. So we have y equals 4/3 x minus 5. Now I'm going to plug these in for x. So we have y equals 4/3 times whatever we're going to plug in here, these x values, and then subtract 5. So y equals, let's plug in a -1. -1 times 4/3 is -4/3, which is -1 1/3. Minus 5 is going to be -6 1/3. So that's what goes here. Okay, now instead of the -1, I'm going to put a 0. Because again, plug in a -1, see what it is, that goes here. Plug in a 0, see what that is, that goes here. 0 times 4/3 is 0. 0 minus 5 is -5. I always like to use 0 because it's very, very helpful. And now plug in a 1. So 1 times 4/3 is 4/3, or 1 1/3. Minus 5 is going to be 3 2/3. Excuse me, -3 2/3. And so we have 3 different points. Now, sometimes it's a little easier instead of using these, and I'll go back and show you this. You notice that we have a 3 as our denominator next to the x. Because of that, sometimes instead of going -1 0 1, we could use multiples of that number, -3 0 3. If you do that, it eliminates all of these fractions, and so you don't have to deal with these fractions and mixed numbers, and can eliminate some careless mistakes there. For the moment, though, I'm going to go ahead and graph these. -1, -6 1/3. Put a little bit past -6. 0, -5. And 1, -3 2/3. So go 1, 2, 3, and almost a 4, but not quite. There you go. And we can graph our line. Probably the easiest way would be using your ID. And again, if you didn't want to deal with these fractions, all you have to do is pick multiples of this bottom number. So instead of -1 0 1, we would use -3 0 and 3. And that way you would not have to deal with these fractions. You would have integers. Now this is what I like to call swat the flies. If you have, number one, let's get y by itself. That's always a good idea. Add y to both sides, and we get y equals 3. So that's what I'm dealing with here. When you're dealing with one variable equations on a two variable coordinate plane, x-axis and y-axis, probably the best way to do this, in my opinion, is to simply look at the y-axis and go to 3 on the y-axis. Well, this is the y-axis, so let's go to 3. 1, 2, 3. And you notice that the y-axis does this. This is the y-axis. But a y equals type of line is going to be like this. So we can simply put the y equals type of line on the y-axis, and we're ready to go. Of course, probably need to redraw this. And again, the basic idea, that's the y-axis, so this is a y equals. If you had an x equals type of line, you go on the x-axis to wherever it is you needed to graph, and then you would graph an x equals, put a vertical line. And that's as simple as it is. Okay, let's look at number 12. Variables x and y vary directly. Immediately, you should know y equals kx. Constant of variation, y equals kx. Okay, so it takes care of that. Write the equation that relates. So, it's telling me to do something. First, I have to write an equation. That's what they're telling me to do. Now, what kind of equation? An equation that relates x and y. So I have to see the x and I have to see the y. When x equals 5 and y equals 20. Then we're going to find the value of y when x equals 10. So you notice Then find the value of y. They're telling me a second thing that I have to do. So when I'm done with this problem, I'll have two things. I'll have an equation, and I'll have a value of y when x equals 10. The first thing was to write an equation that relates x and y when x equals 5 and y equals 20. So I just plug these in. Now, is this my equation? Well, it's an equation, but it does not relate x and y. I don't see x, I don't see y, so this cannot be it. Now, I found that k equals 4, but is this an equation that relates x and y? No, definitely not. So I'm going to plug this back in for k, which is the constant of variation. Y equals 4x. Now, is this an equation that relates x and y? I see x, I see y. Yes, this is part 1 of my answer. Then find the value of y when x equals 10. All right, so what I'm going to do, I'm going to plug in x equals 10 into my new equation that I found. Y equals 4 times 10, so y equals 40. So I'm going to write this in a sentence because it matters exactly when this happens. When x equals 10, I'll tell you what, if I'm writing these in words, might as well go all the way. When x equals 10, y equals 40. And why is it important that I say that part about the x? Well, you can kind of think about a river. Okay? If I'm dealing with a river, it may be, say, 20 feet wide here, but only 5 feet wide here. Now, if I've got a little man here standing at this point of the river, he wants to know how wide is it at this point. He doesn't care about this. He doesn't care about that. He wants to know how wide is it here, so he knows how to safely cross that river. The point is, when x equals 10, y equals 40. Y does not equal 40 across this entire equation, just specifically where x equals 10. Okay, now here's a practical application of this direct variation problem. Income at a store varies directly as advertising budget. Now, here's what I like to do. When they tell me that this varies directly as, the last thing that they write, that's the independent variable. If you're thinking about, in science, dry mix, this is what we can control, the advertising budget. We get to control, so that's our manipulated or independent variable, so that's my x in this situation. Now, the income at the store, that's going to depend on how much we advertise. If we advertise a lot, we'll get more income. If we don't advertise as much, we won't get as much income. And so this responds to my x. So this is my y variable. So that tie between the science and the math, that dry mix, is very important in these direct variation types of problems. Now, it also says varies directly as. Why is that important? I have this nice direct variation equation with my constant of variation, k. When the owner spent $3,000 per month to advertise, so which one is that? Well, it's the x. So I can plug in 3,000 for x. Their monthly gross income was 12,000. So gross income, that's y. So now let's just solve. Got multiplication. We can undo the multiplication with division, or multiply by 1/3000th, either one. K equals 4. Now, here's the important part. If the owners increase their advertising budget to $5,000 a month, how much gross income can they expect? They can expect K equals 4. Well, that doesn't make any sense at all. I have not answered the question. The question is, how much gross income can they expect? This doesn't answer that question. Now, in order to answer that question, let's plug this back in for k. So y equals 4x. If the owners increase their advertising budget to $5,000 a month, okay, well, advertising budget, go back to the original. This is x. So advertising budget 5,000. X is 5,000. Let's plug that in. How much gross income can they expect? Well, y is the gross income. Y would be 20,000. And remember the little man in the river? They're not going to get $20,000 all the time. They're going to get $20,000 if they advertise $5,000 in that month. So when they advertise 5,000 a month, they should expect about $20,000 in income, gross income. What does gross mean? It just means the total before taxes and bills and all that sort of thing. Okay, and there we go. When they advertise 5,000 a month, they should expect about 20,000 in gross income. And as always, let's check to make sure I answered the question. If I didn't, if I found something very nice, but I didn't answer the question, I have not completed this successfully. How much gross income? $20,000 in gross income. Yes, I have answered the question. So that's good. All right, now determine if the given relation is a function. If it is a function, give the domain and range. All right, now for these types of problems, basically the idea is that one input or x can only have one output. Or y. So as I look at this, there's different ways to think about that. Let's look at this one. The input 4 maps onto 0 and 4 maps onto 1. We just said one input can only have one output. Well, that's not the case here. 6 maps onto 4, 8 maps onto 4. That part is okay, but 4 mapping onto two different things, that is not a function. One way to think of this is to look at a door. All right. One person cannot go through two doors at the same time. That makes absolutely no sense. But here, two people could go through one door. That makes perfect sense. So if there's two different things, two different inputs, two different domain values that map onto one range value, that's okay. But if one input, one domain, tries to map onto two outputs at the same time, one person tries to go through two different doors at the same time, that makes no sense. So this is a relation, or you could say it's not a function. You could say either way. Now, if it had been a function, the domain would be 4, 6, and 8. The range would be 0, 1, and 4. Let's look at this one. In this context, it's a little different. 2 maps onto -6, -5 maps onto 1, 7 maps onto 9, and 2 maps onto 0. Well, it's not as clear as a picture as here. So I'm looking for, does x repeat? Let's see. Yes, it does. 2 and 2. Now, does it repeat with different y values? 2, -6, 2, 0. Well, in this case, it does. So this here is the same thing as having these arrows. You're having one person trying to go through two different doors at the same time. That makes no sense. This is a relation or not a function. Okay, use a vertical line test. Well, I like to think of power lines. If you've ever noticed, sometimes you'll see a little bird, might see a little squirrel. I'm not going to try to draw a squirrel. Actually, that probably looks more like a squirrel than a bird. But if they hop onto one power line, that's not a problem. But as soon as they hop onto two things at the same time, two power lines, then you've got a direct connection, and they're fried, basically. That doesn't usually happen because they can only touch one at a time. Now, if the power line hits the ground, you can touch both the power line and the ground. That means you're touching two things at the same time. That means that you're going to get electrocuted. If you can touch two power lines at the same time, you get electrocuted. You don't want to touch more than one power line or the power line and the ground. So what we're going to do is we're going to take a vertical line, and we're going to ask, does it touch the vertical line more than once? Ah, it does. You can see it touches here and here. If it touches more than once, it's like touching more than one power line. You get fried. Is this a function? No. It touched more than one power line, relatively speaking. Okay, let's look at this. Vertical line. See where the vertical line's touching the graphed function here. Or, well, we think it's a function, the graphed relation. Nope, never touches more than once. So, you never touch more than one power line. Is this okay? Yes, this is good. Look at this one. Oops, got shocked. Got electrocuted. It's bad. Nope, this is not a function. Look at number 19. F of x. What do you mean f of x? Well, f of x is function notation. Now, if you'd like to, you can think of this as y, but you really don't want to write it that way because this is a particular notation. You need to stay with the original notation. F of x equals 5x minus 4. You could just think of it like it's a y. Now, this is y equals mx plus b form. M is 5. B is -4. I can graph this any way I like. I could use intercepts, slope-intercept form, table of values, any of those. Now let's just, since it's in slope-intercept form, let's use slope-intercept method for graphing. First, I'm going to drop my anchor at -4. So B is the y-intercept. So I'm going to go on the y-axis to -4. Now I'm going to aim rise 5. Wait a minute. There's no rise and run. Easily remedied. Simply 5 firsts right as a fraction. And now I can rise and run. So I'm going to rise 5 from the boat. 1, 2, 3, 4, 5, and run 1. Oops. I did not want that line. And there we go, it's graphed. Find the slope of the graph of the linear function given f of 5 equals 7 and f of -1 equals -5. Well, the good thing about this is that we know that f of x is our normal notation. That means that 5 is the x, and this is actually the y. So this is really just 2 points. 2 points. Now I can use my slope formula. y sub 2 minus y sub 1 equals x sub 2 minus x sub 1. Or you could simply use the puppies. Remember, the puppy faces the right, the 7's on top, 5 kind of dangles underneath, negative 5 is on top, the negative 1 sort of dangles underneath. We're going to subtract these in the fraction form. Keep, change, change, keep, change, change. M equals 7 plus 5, 12, 5 plus 1 is 6, m equals 2. Have we found the slope? Yes, we have. Okay, one last problem on our review. All right, algebraically. Now for the algebraically, we'll use the little song, the Elvis song. First distribute, then combine all of your like terms. Please remember, keep, change, change, or you will get burned. Then get all your variables onto the same side. Well, that's not necessary here. First addition or subtraction. Then multiply, divide. And there we go. We know that x should equal negative 2. Well, normally I could just plug this in to check, plug it in for the x value, but I'm going to check it out, I'm going to check it graphically. Well, what does that mean? First, I have to find 0. So I'm going to find 0 on one side. Let's see, let's start over here, 2 onto x minus 1 minus 5x equals 4. I'm going to distribute first. Combine like terms. And I'm going to get 0 on this side. So I'm going to subtract 4. So I found 0. Now we're going to replace 0 with y. So instead of that 0, I'm going to put a y. Now, why would we do that? What we're going to do is we're basically going to replace the 0 with a y, graph it, and see where y equals 0. Basically, where does it hit the x-axis? Because x-axis is where y equals 0. So let's go ahead and graph this. I'm going to use Moby in the boat, slope-intercept form. Okay, b equals negative 6, m equals negative 3, but I'm going to put it in fraction form. So I can have my rise and my run. Okay, drop your anchor. B is the boat. Y-intercept. So on the y-axis, negative 6. Rise, negative 3. Run 1. Now, I want to find where y equals 0, namely the x-axis. If I keep going this way, I'm going the wrong direction. So I'm going to go the other direction. Instead of negative 3 over 1, I'm going to say 3 over negative 1. Put the negative in the other location here, in the denominator instead of the numerator. So now I'm going to rise 3 and run negative 1. 1, 2, 3, run negative 1. Now I'm heading the right direction. I'm trying to hit the x-axis. Again, rise 3, run negative 1. So now I have actually hit the x-axis. That's what I wanted. Now I can graph my line. Why am I putting extra points here? What I'm trying to do is I'm trying to get a greater accuracy. You can think about, if you think about a sawed-off shotgun, very short barrel, so not extremely accurate. If you think about a long rifle, very long barrel, so it's going to be much more accurate. So what I'm trying to do is these graphed points are sort of the barrel, if you will, of the gun. We're trying to get increased accuracy by lengthening that barrel and making sure I get exactly on the x-axis, which is what I want. So where does it hit? Where does y equal 0? At negative 2. So x equals negative 2. So my process, find 0 on one side, replace 0 with y, and find the x-intercept. Those are my steps, and we're ready to go. Again, folks, I would really suggest that as you're doing this review, go through the video, pause as soon as I get to one of the questions, try it on your own, then play the video, and if you didn't get it right, simply rewind the video, pause it again, and try the problem a second time, or a third time, or a fourth time. It's better to try to get the full depth of the problem as you continue to practice these. So use this video, find the ones that you're having the most trouble with, and pause, rewind the video until you're able to practice this on your own, until you can get fluency in the numeracy here. Thank you very much, and thank you for watching the video by Crazy Math Productions.